Alrighty, here is your calendar for today. This was over here because yesterday I thought I could get through this and get this started, but I'm glad that I didn't. I didn't need to stress y'all out even more about that. So I just moved it to over here, and it's going to go on page 105. But as we're going through this, I want you to have page 101 handy. As we've already talked about SOHCAHTOA, that's a review from geometry, and the trig ratios and which ones are the reciprocals. Because we're looking at this again today. I'm not going to rewrite which ones are the reciprocals of each other. Just kind of expect that you know that. And so have it handy as we go through this. And this is going on page 105 when we are done. Okay, so if you are given a point on the unit circle, you can find the other 6 trig ratios, all 6 trig ratios for theta in simplest radical form. So remember that for a unit circle, your ordered pairs, x, y, is cosine theta, sine theta, and that tangent theta equals sine theta over cosine theta. And then your acronym for trig is SOHCAHTOA, S-O-H-C-A-H-T-O-A. Means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. All right, so if I draw on my picture here, I have a point that, let's say, starts here, and then it rotates around to somewhere. Right here looks good. I have this. That makes this angle right here theta. I just had to pause, so I have no idea what my last sentence was. But what I was doing was this rotated around here. Here's my theta. So I'm going to make my right triangle by dropping my perpendicular down. Gets my little triangle here. Now this ordered pair here, which is x, y, this length here, this is my x value, this is my y value, and this is my radius, which is, if it's a unit circle, is 1. All right, so here's what I know from trig and from SOHCAHTOA, that the sine of theta, oh my goodness, that does not say sine. The sine of theta, it is opposite over hypotenuse. So if this is theta, this is my opposite, this is my hypotenuse. So y over 1, which is just y, which we already knew because that's coming from there. Cosine of theta is adjacent over hypotenuse. So that's x over 1, which is the x value, adjacent over hypotenuse. So it is just x. Tangent theta, let me get this from a few different ways, because we should know that tangent theta is sine over cosine. So it's just y over x, but we also know that it's opposite over adjacent. So it's the opposite over the adjacent, which is y over x. Okay, so the reciprocal of sine is cosecant. That is 1 over y. Then the reciprocal of cosine is secant. That is 1 over x. And the reciprocal of tangent is cotangent. So when I take that reciprocal, I get x over y. So that is how we are going to come up with what we need to find the 6 trig ratios of a point that is here on our circle. So we're going to start with this one. Now, at -3 square root of 2, and I'm sorry, -3 over the square, oh my gosh, negative square root of 3 over 2, 1/2, then I'm over here at -3 squared, oh my gosh, I cannot say that. This number right here, negative square root of 3 over 2, 1/2. Okay, so like I'm about right here, something like that. So here's that point. Right? So here is my theta for this one. Now you don't have to draw the picture like every time. I just want to make sure that we're all understanding what's happening here. So if I'm here, think about what your reference angle and what your actual angle is here. So it's this angle that we're finding the sine or cosine of, but this is where your little right triangle comes in. So the theta here is 5 pi over 6. Okay, doesn't have to be all drawn out there. This is not necessarily even relevant, but this is what we have. All we really need is to know how these work here and to know what our ordered pair is. So, sine theta. Remember your ordered pair is cosine sine, so sine theta is just 1/2. Just get it straight out of the ordered pair. Cosine theta is your x value, so that's negative square root of 3 over 2. Finally was able to get that out of my mouth. Tangent theta, okay, that's opposite over adjacent if you want to write that out. It is also just sine over cosine. So sine over cosine, this is going to give me 1/2 over negative square root of 3 over 2. So when I divide fractions, that's actually 1/2 times a negative 2 over the square root of 3. So those cancel out. That's going to give me negative 1 over the square root of 3. That's a bad thing. Can't have square root in the denominator, so I rationalize. When I multiply by the square root of 3 over 3, the square root of 3 over the square root of 3, that gives me negative square root of 3 over 3. There is your tangent theta. Okay, I should have boxed the rest of these. All right, then cosecant. So cosecant is the reciprocal of sine, so I should have had this up here. So my sine is 1/2. The reciprocal of 1/2 is 2. It's just that easy. Secant is the reciprocal of cosine, so I take the reciprocal of my cosine, or, I mean, I can look at it as 1 over the x value, which is the same thing. But it's the reciprocal of cosine, so it's negative 2 over the square root of 3. But I have a square root in the denominator, so I have to rationalize. When I multiply it by the square root of 3 over the square root of 3, it's going to give me negative 2 square root of 3 over 3. I don't know what just came out of my mouth, but I keep saying that wrong. When I have to multiply this by, let me write it down so I can make sure. I'm multiplying that by the square root of 3 over the square root of 3. I think sometimes I'll leave out the second square root, but that's what I'm doing to rationalize. And this is, my answer is right. I just can't get the words out of my mouth for some reason. There you go. Okay. Then cotangent is the reciprocal of tangent. So here's what I had at tangent. Now if you look at this, I can take the reciprocal of this and then rationalize, but this right here came from this one. And this was bad because the square root was in the denominator. But if I take the reciprocal of this, I'm going to have to rationalize. But if I take the reciprocal of this at this stage, then I won't have to, and I just get negative square root of 3. All right. I was about to say any questions, but if you have any questions, then I guess you need to pause and ask your neighbor. We're not going to do the right-hand side. I don't know that that's necessary. That's part of the ones on your homework anyway. But that's where you get that straight from the unit circle. We've already done some of those. What we're really looking at today is what's happening when it's not on the unit circle. So that's what's on the inside. So let's look at what's happening in here. So it says if you're given a point on the terminal ray of a standard position angle, theta, you will need to use Pythagorean Theorem to find the other 6 trig ratios in simplest radical form. So that means that this here is not the unit circle. So if I have a circle, it's either not the unit circle or I don't know what it is or whatever, then I'm going to go ahead and just pretend like my point rotates around to the same kind of place there. I should draw that and then do my point. Get my right triangle. So here's my right triangle. Now, this is still xy. This is still my x value. This is still my y value. This is still my radius. This time the radius just does not equal 1. Okay? And I still need to think about SOHCAHTOA here. And let's look at what our 6 trig ratios are if this is theta. So your sine theta, which has just been the y value. Is it just the y value because this is not a unit circle, okay? Not the unit circle. And so my sine is opposite over hypotenuse, so that makes it y over r. That's what it was on the unit circle too. R was just 1, so that was kind of irrelevant. Then cosine theta is adjacent over hypotenuse, so that's x over r. Tangent theta is still just y over x. It's also still sine over cosine because the radius cancels out. All right, so sine is cosecant theta. The reciprocal of sine is cosecant theta. That's what I meant to say. And so the reciprocal of y over r is just r over y. Reciprocal of cosine is not sine. It is secant theta. And so that is r over x. And the reciprocal of tangent is cotangent, and so that is still x over y. So that is how we're getting these. The difference here is that what we're starting with, this right here, this is my ordered pair. And it's not on the unit circle, so I don't know what the radius is. So we're going to go ahead and semi-plot this point somewhere right about here. Okay, that would not be where that is. -1, -2. So -1, -2, just, it's fine. We're just eyeballing it just to get the idea of what's happening here. So here's my triangle using that reference angle. So this is -1. This is -2, and this is my radius. So that's where the Pythagorean theorem comes in, is that I have to find what the radius is. So just in general, for this, my little right triangle, I know that x squared plus y squared equals r squared. So the radius is just equal to the square root of x squared plus y squared. So you can substitute it right into that, or you can just think Pythagorean theorem. It's the same either way. Just be careful with your signs. So you could substitute it into here. I'm just going to stick with Pythagorean theorem. I think that's more likely what you're going to remember. -1 squared plus -2 squared equals r squared. So this gives me 1 plus 4 equals r squared. So r squared equals 5. So r equals the square root of 5. You leave it in simplest radical form, no decimals there. So there's my radius, square root of 5. And then my ordered pair, I'm just going to rewrite it here so that I can see it. I've got -1, -2. So there's my x, y, and my r that I need. So when I look over at, or if you think about what your sine is, it's the y value over the radius. So my y value is -2. My radius is the square root of 5. Okay, cannot have a square root in the denominator. And just in case any of you are not following me when I rationalize quickly and without showing work, I'm actually multiplying by the square root of 5 over the square root of 5. I'm not going to write that down every time, but that's what's happening. So I get -2 square root of 5 over 5. That's your sine theta. So you can pause and try the rest of them if you want, but I'm just going to go ahead and work through the rest of these, and maybe you try the next one on your own. Cosine theta, so that is going to be x over r. So your x value is -1 over your radius, which is the square root of 5. So when I rationalize, it's going to be negative square root of 5 over 5. Tangent theta, that is y over x. So your y value is -2 over your x value, which is -1. So that becomes +2. Cosecant. All right, so cosecant is the reciprocal of sine. So again, you got two options. I can take the reciprocal of this. When I do, then that's going to put the square root in the denominator. I'm going to have to rationalize. Well, I got here because I started with this and then rationalized. So these two pink fractions have the same value. They're just in a different form. Remember, the value is exactly the same if you type it in the calculator correctly. But it's like having 4/8 and 1/2. It's just, it looks different. So instead of taking this and having to rationalize, I'm going to take the reciprocal of this one. So that's just going to give me negative square root of 5 over 2, which is what I would get if you just know that cosecant is the radius over the y value. So I'd have square root of 5 over the -2. That's where it's going to come from. Okay, so let's look at secant that way. Secant is the reciprocal of cosine. Cosine is x over r, which means secant is r over x. So r is square root of 5 over x, which is -1. So that's just a negative square root of 5. And then tangent, or cotangent rather, is the reciprocal of tangent. So this is just -1 over -2. I could have just taken the reciprocal of 2. Either way, I get 1/2. You aren't always asked for all 6 of them. When you are, you can use the first 3 that you have to help you with the second 3. If you just have to get one of these, then you're going to have to know, how the fractions work for you there. All right. Okay, so next one. This says the exact same thing as it did on the other one. This is not the unit circle. And so let's go ahead and we can plot this point. Commit 2, -3. I'm just eyeballing it. It doesn't even matter exactly where it is. And here is the triangle. Here is my theta, whatever it might be. Don't even care. This is 2. This is -3. And this is my radius. Okay, so I do Pythagorean Theorem. 2 squared plus -3 squared equals r squared. So 4 plus 9 equals r squared. R squared equals 13. So r is the square root of 13. And my ordered pair is 2, -3, which is right there, but it's just kind of tiny. So these are the 2 things I'm using here. My x and y value and my radius. So I would suggest on this one that maybe you pause this and try and come up with these on your own, and then you can check yourself. But I'm going to continue going. So if you want to do that, you have to actually pause. So sine, I know, is y over the radius. So my y value is -3 over my radius, which is the square root of 13. I have to rationalize, so that gives me -3 square root of 13 over 13. Cosine is my x over r, so that's going to be 2 over the square root of 13. So that is 2 square root of 13 over 13. Tangent is y over x, so that is going to give me -3 over 2. Can't simplify that, so that's that. And cosecant is the reciprocal of sine. Sine is y over r, so this is r over y. So this is going to be square root of 13 over -3. That's all I can do there. Secant is the reciprocal of cosine. Cosine is x over r, so this is r over x, which is the square root of 13 over 2, and that's all I can do there. Cotangent is the reciprocal of tangent. Tangent is y over x, so this is x over y, which is 2 over a -3. Now, there are some questions on the homework that are not identical to this, but you use the same concept. And I purposefully did not do examples like that because I want you to think. You need to think on your own about how you would reason through these and how you use what you know and these concepts to use what they've given to you to kind of work backwards and find what you need to find. Okay? So do your best on this. Remember, what I gave you yesterday is due tomorrow. You don't have to turn it in today. I'm sorry that I'm not there to answer your questions if you had any further questions on those, but I will be... But you can go to tutorials with Miss Rice or Miss Archer or Miss Ferris, who is next door to me. She can totally help you with pre-cal stuff too. None of us have MAV time today, but we will have MAV time on Wednesday. And as always, I will clear up anything that doesn't make any sense to you. You just have to be willing to ask. All right? So do your best, and I will see you tomorrow.